Hello and welcome to our session Say Goodbye to Downtime High Availability Solutions for SAP S/4HANA. This is a sponsored session by SAP and it will be co-presented by colleagues from SUSE and SAP. But let's first introduce the speakers. So my name is Markus Gürtler. I'm the manager of the SAP High Availability Solutions team, and I'm also a member of the SAP Linux Lab. And with me is my valued colleague Ralf Cekala, product manager at SAP, and my colleague Fabian Herschel, who is distinguished architect at SUSE and also member of the SAP Linux Lab. Yes, let's quickly go through the agenda. I will talk in the beginning very shortly about the difference between high availability and disaster recovery for SAP S/4HANA. Then Fabian and myself, we will give an introduction to our high availability solutions for SAP S/4HANA. Then Ralf will talk about the advantages of moving from HANA 1.0 to HANA 2.0. And last but not least, we will give an outlook from SAP and SUSE about our latest developments and technologies that we have on our roadmap. So let's start with the concepts of high availability and disaster recovery. So here on this illustration, you see three sites. This is site A, site B, and site C. And these sites can be either on-premise or they can be in the cloud. It can be also a mixture of both of them. For example, site A and site B on-premise and site C in the cloud. And we have three SAP HANA scale-up systems configured here and system replications between those scale-up systems. So we have a system replication from site A to site B and a system replication from site A to site C. So let's start with the system replication on the left side from site A to site B. So this one here is a clustered synchronous SAP HANA system replication. That means that the system replication is completely controlled by our SUSE high availability cluster. This means in case of a system failure of the HANA scale-up system on site A, the HANA scale-up system on site B can completely take over automatically since it's controlled by the cluster. This has the advantage that the failover times are really low and therefore the availability of these systems is rather high. So it's basically a real business continuity solution and therefore it's one of the high availability scenarios. The limitation is that the sites have to be nearby. If it's a cloud case, usually these are in two different availability zones in one region, or if it's an on-premise use case, then it would be two data centers which would have a distance of maybe 30 kilometers, of course, depending on your network latencies and other parameters. In case of a real disaster, for example, let's take an earthquake. There is a probability that both sides go down, so site A and site B. And in this case, of course, you like to continue with your services as well, and you can do this on your data recovery side, site C in this case. Therefore, we have the second system replication from site A to site C, which is not in the cluster and which is asynchronous. This means that data can be lost, but the SAP HANA database ensures data integrity. Single transactions can be lost. And it's not controlled by the cluster. So that means if a disaster happens, there have to be manual interactions to get the data recovery SAP HANA system running. So you have to make a manual SR takeover and probably also some network reconfiguration to get it running. The disadvantage here is, of course, this takes much longer. But of course, the advantage is that the site C can be much far away. For example, in a cloud case, it can be in another region, or in an on-premise case, the data center C can be in another country, for example. I'd like to note that these scenarios are working with HANA Scale Out as well. Even so, this is not yet supported by SUSE, the so-called multi-target system replication, but it's already in testing and it will be supported soon. And of course, you can also use the optional auto-host failover from SAP, which increases the availability further. Yeah, and with that, you now have a little insights into the basic concepts, and I'd like to go now into the software that SUSE provides for SAP S/4HANA high availability. And if we talk about software, we always start with our operating system for SAP, which is the SUSE Linux Enterprise Server for SAP applications. And SLES for SAP is a bundle of software and services based on our operating system, SUSE Linux Enterprise Server, to run SAP workloads on top of it. We have technical and non-technical features integrated into this product. Non-technical features are, for example, our extended service pack overlay support, SPOS. This gives you a longer support lifecycle time in case a new service pack comes out. So you have a longer migration time until you have to migrate to a new service pack. Also, our 24/7 priority support is included there. As technical features, we have our sub-tuning included, like Subtune, our workload memory protection, our deployment automation solutions that allows you to automatically install SAP HANA systems and also automatically configure the high availability clusters. But we have also included all components that are needed to make SAP S/4HANA systems high available, which includes our high availability extension, our SAP S/4HANA HA resource agents, and the SAP SUSE cluster connector. And all those features are integrated into the product. So if you buy a subscription of SLES for SAP, you get all those features to make SAP HANA or S/4HANA high available with no extra cost. It's important to note that the latest version of the SLES for SAP operating system is version 15, Service Pack 2, with Service Pack 3 standing right on the door. There is a very interesting session available from my valued colleague and product manager, Christian Heusing. It's called SLES for SAP Applications, The Road Ahead. So if you want to learn more about our product, I highly recommend to visit Christian's session. Yeah, and with that, I'd like to go a bit deeper into the high availability solution we have from SUSE for SAP S/4HANA. First of all, if you talk about high availability for SAP S/4HANA, we have to get in mind that from an infrastructure perspective, we always talk about two different SAP components. We have the SAP HANA database on the one side and the SAP application server ABAP on the other side, and both have to be made high available. The SAP HANA system replication automation that I just showed before is one of those solutions to make the SAP HANA database high available. And the high available ASCS with the NQ replication, the answer 2 scenario is the one for the high availability of the SAP application server. As cluster technology, we use the high availability extension based on Pacemaker and CoroSync. We have dedicated cluster resource agents for SAP HANA and the SAP application server ABAP included into our product. We have major fencing concepts available, like our Stonelit block device. We have other fencing concepts also for the public cloud providers. Then we have a very sophisticated set of configuration guides and best practices, and also man pages available by SUSE and also by various public cloud providers. I always was mentioning our automatic deployment to automatically install SAP HANA, SAP NetWeaver, and also the configuration of the high availability clusters, which is then basically referring to the day 1 operation and simplifies that. We also have for the day 2 operations our monitoring solution to monitor SAP HANA and our cluster stack. And these solutions are available for on-premise use cases and on the public cloud providers, Azure, AWS, Google, and Alibaba. So with that, I'd like to give a short example of a SAP S/4HANA cluster with both components, clustered both components. So here on this illustration on the right side, you see our SAP HANA system replication with 2 HANA nodes in a scale-up configuration with our cluster solution that automates the system replication. We also take care of the failover of certain infrastructure components like virtual IP addresses. And on the left side here, we have a scenario to make the SAP application server high available with the ABAP system central services instance here on the left side, and the NQ replication server on the right side, so node A and node B, which are also then configured in a cluster. Also here we make certain infrastructure components like the IP addresses and also optional file systems high available. In this case here, the primary application server and the additional application server are not in the cluster. It's also worth to mention that this is an AWS example, but it works completely the same for on-premises use cases and other cloud use cases, of course. I'd also like to mention that there is an integration of the ENSA 2 scenario with the start-stop framework, and this is also SAP certified here, in this case with the S4 HANA 1809. And this integration ensures that there is a communication happening between the stop framework and our cluster. So, for example, if you perform an action with the stop framework, for example, stopping an HCS, it's made sure that this gets then communicated to the cluster, and actually the cluster does then the actual action to stop the system. There's also an integration into the sub-management console available. That means that you can control the cluster status also from the SAP management console. Yeah, and with that, I'd like to hand over to my colleague Fabian Herschel, who gives you an introduction of the different scenarios we have about the SAP HANA system replication. So over to you, Fabian.
Yeah, thanks, Markus. So here you see on this slide the major 4 kinds of replication scenarios we discuss about. On the upper left, you see the performance optimized. Markus already told about that. It's a replication between 2 HANA nodes and could very fast process the takeover. Once the cluster detects an outage on the primary side, it automates the takeover to the secondary side and guarantees that the IP address is being placed well. You can also use this with read enabled. We'll see that on the next list. You have an option to do it a bit more cost optimized. If you want to have a non-replicated system on the secondary side, this is the second scenario here on the slide on the upper right. You can place, for example, an QA or whatever system there. And then you need to shrink the primary, the secondary system, which gets the replication on this side. So both fits into the memory. This is how to save the costs of the nodes. And this has some advantages. You can use cheaper systems, but on the penalty side, it takes longer to take over, because once the primary would fail the cluster first, needs to stop the non-replicated system, then doing blow up of the HANA secondary to be the new primary. Multitarget, Markus already explained that, is that now going from chain to multitarget, a single source could replicate to multiple nodes, and this improves the cluster architecture and makes it much more smooth to consume for the admin. And last not least, we have the performance optimized thing also for scale out. And with that, we come to our list of scenarios. Here you see some kind of scenarios grouped by scale up and scale out. Some of them are already supported from the beginning of our journey through SAP HANA system replication automation. Others are in place now to come in. Markus already told that Multitarget is already supported for scale up and will now also be supported for scale out with the next bigger package update, which will be 0.180. And with that, I give back to Markus.
Thanks, Fabian. And now we go to the next section in our agenda, which is the advantages of moving from HANA 1.0 to HANA 2.0, which will be presented by Ralf.
HANA 1 is already for quite some time in support. We released it in June 2016, so 5 years ago nearly. So today we have the end of maintenance ahead of us, and with the next step you can see the that we developed over time HANA 2.0 quite nicely. The recent step was SPS 04. Also, this SPS 04 is now already 2 years in support, and we started last year SPS 05. Again, SPS 05 is a 5 years support, long-term support release, and end of maintenance is planned for June 2025. So it's very important now to keep in mind that we are shortly before the end of maintenance. End of maintenance here means that we are not able anymore to offer patches. Of course, we still support you in determining problems, so you can still open up support messages, tickets at SAP. We will look into these topics and take care that you have the best support you can expect. But there could be situations that the only means to solve things to put and create a new patch, and this will not be possible anymore after the end of maintenance in June 2021. So actually end of next month. So take care that you switched to HANA 2.0, and HANA 2.0 gives us really nice new features, and I tried to collect them, to summarize them, and make them as tangible as possible to you. So one of the biggest developments in HANA 2.0 is an active read enable option. You see in the picture here, in the illustration, in the bottom part, it's what you see already before. It's a high availability solution, and with a high availability solution, you typically have to buy more hardware, bring in redundancy, and this hardware so far was sitting there doing more or less nothing. So with active, we can utilize this hardware for real business cases, for the primary business cases on the left side, where the application are extended with SQL hints. Or you could also use it with dashboards, BI tools, and have a pure read option to bring in even more security to this operation. So with the next column, you see the next big thing we invested in HANA 2.0 is data tiering, allowing also to keep data which is not very often attached and touched on more cost-effective spaces, typically the disk, and still have a good access option to that. So if you have here and there access needs to this data, it's still in reach and performant. This is, for example, named NSE, Native Storage Extension for HANA, and came out recently. On the next column, we see another means of optimizing HANA 2.0 with the support for persistent memory. Of course, you can use a persistent memory in a very, I would say, dumb way, simply using it as the DRAM as cache instead of really adapting to this new technology. And HANA can do that. HANA has the capability to know exactly what are the capabilities of PMEM in contrast to the DRAM, and optimize its operation accordingly. And in the lower part of this column, you see that the startup times are benefiting from that enormously, and can also offer us much bigger boxes than we have today. On the next column, we see multitenancy. And multitenancy is another very important step because it allows us to have mass operations in HANA. Mass operations meaning you can run multiple applications on the same database hardware instance. And if you need or have leftovers in the hardware, you easily can create another tenant for test purposes aside of other usages, because it's simply free, this hardware. And of course, we can separate these tenants accordingly. We can configure them for joint data usage, as you can see, or combine it and separate it. On the next column, we see the next big thing. With the tenants introduced, we now can also move them, like you know it from virtualization technologies, where you use motion technologies to move tenants around. And HANA as a database can offer here similar capabilities to move tenants into spots where we have free spaces, and also extract tenants out of such a setup to new hardware because they grow. On the next column, we see another nice feature to optimize the restart capabilities of HANA, named Fast Restart Option. Here we are using the capabilities of Linux, offering us as a standard the TempFS. And TempFS is a file system operated by the operating system, and the operating system can offer us here to keep the memory alive beyond restart of the database. And this is the benefit for the HANA system running the business now in a structure where the operating system can guarantee to keep it alive when the database does a restart accordingly. On the next column, we have the multi-target replication we already saw from Markus and Fabian. Multi-target allows us now to have not only one string of systems, a line of systems. Instead, we can have a lot of systems on the side. It's to reach high availability, to have the better arrangements, be more flexible for the design of the data centers. On the next column, you see secondary time travel. This is another option of HANA 2.0 to allow us to fix human errors simply by having and utilizing again the secondary system, not only for active-active. Here we are utilizing it to allow the system to run behind and still be fed while it's running behind, with new changes coming from the primary and flowing to the secondary. We are using built-in snapshot technologies here. So if you decide you need to get back in time travel, then we can fetch the most fitting snapshot, bring it up to full operation, and with the read capabilities from active-active, we can do it even while it's still in the replication mode. On the next column, we see another very important development, capture replay. Here we have a real-world test bench, meaning if you have a production system in the picture on the left side, we can record the business running really on a really deep database level, and we can record it and replay it as often as we like on a test system on the right side. And with that test system, we can change parameter settings and figure out what does this have an effect on the on my business already on the test system, by replaying the business again and again, as long as we find the right parameter settings or we are convinced what we do here is exactly the right step. On the next slide, we have on the next column here, yes, we have landscape management. Another very important development in SAP. Landscape management is an orchestrator for us, for the database, for the application layers. Even it can interact with the operating system and physical pieces of the setup. This orchestrator allows you to run also high availability and disaster recovery solutions. But on the next column, you will see this landscape management is a customer triggered technology, meaning it is not acting autonomously. like a cluster manager from SUSE can do. And this you find in the lower left part of this picture. The cluster manager is orchestrating the HA side of the picture. So he is managing autonomously the availability of the database for the application. But he is getting out of the picture as soon as we talk about DR. And we have today a lot of customers with DR system, and of course they have demand for automating also these technologies. For that, we can fill the gap with landscape management. Of course, you could also create your own scripts if you want and automate it with your own technologies. But if you want to have a solution from SAP, SAP Landscape Management would fill the gap and control the DR takeover, will activate then later on also again the SUSE cluster on the secondary side to take over the autonomous operations below the landscape management layer. Okay, with that, we come to the next piece. Okay, we have also documentation here available, as you can find later on also in the handouts. Let's have a look to the future outlook from SAP and SUSE. And on the next slide here, you see that we have SPO 6 ahead of us. You saw it already on the slide before. It is planned for December this year. Again, with a maintenance of 2 years, in contrast to SPO 5 having a maintenance of 5 years. Here we have planned several extensions in the area of backup recovery, for example, compressing backups before you encrypt them, very useful. And again, security, it's getting bigger and bigger, this topic. We want to have a security feature always on. So if you install HANA by default, then that you have the full fledged security. And finally, again, like with SPO 5, also quality is in focus very strongly. With that, I would like to hand back to Markus Gottler.
Thanks, Ralph. So from SUSE side, I'd like to mention in the Outlook section our SAP HANA Scale-Out Multi-Target that we already mentioned 2 times here in this session. This will be available very soon. We are also working on an SAP HANA SR takeover blocker, which increases the data integrity in case if an administrator does manual interactions with the SAP HANA system replication, for example, from the SAP HANA cockpit. We are planning to do additional sub-application server ABAP HA interface certifications. And last but not least, I'd also like to mention our project Trento, which will be a SUSE console for SAP, which will, for example, include a high availability configuration checker to make sure that everything is configured correctly. It will also have a cluster manager, which has the SAP perspective on the cluster, so simplifies the administration of SAP S/4HANA clusters, especially also for SAP basis administrators. Yeah, and with that, we are through our session, and I'd like to thank you for attending. Of course, there are other sessions available as well by my valued colleagues from my team, Fabian and Lars, but also from other people, also from our emerging SAP solutions team. And those sessions are also highly recommended by us to visit. With that, thank you again for visiting and have a lot of fun on the SUSECON Digital 2021. Thank you.